Hey everyone, this is Dr. Walker. I'd like to do example 565, number 2, finding the magnetic force on a moving charge using vector notation. In this example, we have a proton that moves with a velocity v equals 3i plus 3j meters per second in a region where the magnetic field is b equals 3i plus 3j teslas. What is the magnetic force on the proton? So we know that the magnetic force can be written as a cross product, F equals Q V cross B. We know that with cross products, when two vectors are parallel, the cross product is equal to 0. In this case, V and B are parallel to each other since they have the same exact direction. Therefore, the force on this moving charge is just 0. So I want to go ahead and change up the problem a little bit so that we could practice using the cross product. Here are the new numbers. V equals 2i minus 4j plus k meters per second, and B equals I plus 2j minus k teslas. Now let's go ahead and use the cross product and find the force on the proton. As a reminder, the cross product of two vectors can be written as a 3x3 determinant, and this in turn can be written with 2x2 determinants as follows. So just a reminder, the way it works is you do the determinant of these 4 here times I, which is this first term here, and then you do the determinant here, which is these 2 and these 2, times j, but this term is negative, and then you do the determinant of these 4 over here in the k direction. Let's go ahead and solve for that. To find a determinant, we do this term times this term minus this term times this term. So negative 4 times negative 1, which is 4, minus 1 times 2, minus 2. This is going to be I direction, minus 2 times negative 1, which is negative 2, minus 1 times 1, which is 1, in the j direction. And then 2 times 2, which is 4, minus negative 4 times 1, which is negative 4, minus a negative 4 in the k direction. So this leaves us with 4i minus or plus 3j plus 8k. This is the cross product of v cross b. And now to find the force, we need to go ahead and multiply all of this by Q V cross B. So we can plug in the charge of the proton, which is 1.6 times 10 to the negative 19 coulombs, and then we can just multiply it by the cross product that we just found here. 4, and this is supposed to be 2, not 4. 4 minus 2 is 2. That was a little typo there. 2i plus 3j plus 8k. So this is the force, it's in newtons. We have a direction, so we have a vector. So this is a good final answer. Now, if the problem wanted to know the magnitude of the force, if you wanted to find that magnitude, you could do that as well. What you would do is you would multiply the charge here and by the magnitude of the vector, and to find the magnitude of the vector, it's going to be the square root of 2 squared plus 3 squared plus 8 squared. Right, you just square each of the components here. And you plug all of this in the calculator. We're going to get 1.4 times 10 to the negative 18 newtons. So this is if it only wanted a magnitude, but if it wants it in vector form, then this first answer is perfectly acceptable.